So again, our new unit is on percents. So our learning target for today, Daniel and John Luke. John Luke. Our learning target today, I can identify if a relationship is proportional using our cross product method. I can solve for a missing value in a proportion, and I can solve a percent proportion by properly labeling the parts and wholes of a problem. Okay, so there's a lot of different learning targets, a lot of I can statements in just this particular lesson. But again, this is a really solid review of what you learned first semester in 6th grade. So you want to make sure that you are paying close attention because, again, even though it is a review, some of you may not have done so well, so you want to make sure you're paying close attention. I would recommend right now, in fact, I'm going to pause it for a second, I would recommend that you take out a green and orange highlighter. And a pink and blue highlighter. So we're starting off with our proportional relationships. And first thing that you need to make sure you understand, a proportion, guys, it's just an equation saying that two ratios or rates are equivalent. When we talk about a ratio, a fraction is a ratio. So equivalent fractions, that is an equation. When we're saying 6/8 is the same thing as 3/4, they're equal to each other, we're making them equivalent. A really quick way that you're able to test whether something is equivalent or not, especially if you're dealing with maybe decimal values within inside of your fraction, so you're not quite sure whether they would simplify to the same thing or not, you can use that cross product, meaning that you can take your diagonals and multiply them. So I could take 6 and multiply it by 4, which is just going to give me 24. And that is supposed to be equal to the other multiplication. So if I were to take 8 and multiply it by 3. So when we do 8 times 3 or 3 times 8, whichever order you're multiplying, because again, remember, 8 times 3 and 3 times 8 are the same because of the commutative property. That is also equal to 24. So the fact that they are equal to each other does make that a proportion, a proper proportion. Okay? You can test them out all the time. Like let's say that we have 6/9 and I want to check to see if this is truly a proportion or not to 9/15. Again, all I would have to do is just multiply my diagonals. So I would do 6 times the 15. What's 6 times 15? What's 6 times 15? Okay. And then I want to know, is that going to be equal to 9 times 9? What's 9 times 9? 81. Are those equivalent? No. So this, I just flung myself, is not a proportion. Okay, so the very top one, this is considered to be proportional. This is non-proportional. Okay, so what I want you guys to do is for problems 1 through 4, you're going to check to see if they are proportional or not by doing the cross product. You're going to be multiplying your diagonals and checking to see if they are equivalent or not. Okay, let's go through these. For problem number 1, is it proportional or non-proportional? Non-proportional. Number 2 is proportional. Okay, 3 is proportional, and then 4 is non-proportional. Good. So if we take a look through here, I'm just going to go ahead and quickly highlight my diagonal so I don't have to keep getting mine. Okay. So for problem number 1, we were doing 5 times the 3. 5 times 3 came out to 15. And then we were doing 8 times 2, and 8 times 2 came out to 16. They are not equal to each other, therefore that makes it non-proportional. Okay, when we're taking a look at problem number 2, we had 7 times the 6, which came out to 42. And then we had 3 times the 14, which also came out to 42. So that makes them equal to each other. That makes it a proportional relationship. Okay, for problem number 3, we did 6 times 20, and that comes out to 120. And then we have 8 times the 15, which also is going to yield 120. Those are equal to each other, so it makes it proportional. And then our last one, we had 16 times 6, that's going to come out to 96. And then we have 9 times 11, which comes out to 99. Those are not equal to each other, therefore that is considered to be non-proportional. Okay, any questions about proportionality within ratios? Right, pretty simple, quick review again. All right, go ahead and flip it on over to the back. So on page 2, we're using that same exact concept of proportionality with solving for a missing value. Now, before in 6th grade, you guys actually started this unit before you learned about equations. So the way that you learned it is you go, oh, I'm going to multiply and then divide. But the reason that you're doing it is because, again, you're setting up an equation. In 7th grade, you need to be able to look at a proportion and correctly identify the proper equation that would be set up in order to represent the proportionality. Okay, so for here, when we have the 11 over t is equal to 100 over 11, again, knowing that we can do our cross product, that these are supposed to be equal to each other, then this essentially says that when I multiply 100 times t, this is supposed to be equal to when I multiply 11 times 11. So when I'm creating my equation, I actually have the equation 100t is equal to 121. And then, of course, I can go ahead and solve. We know that once we've multiplied, we then can divide by that 100. Okay, again, it's important, just as equally important, to know that this equation represents this proportion. You will have problems in which you are having to correctly connect the equation to the proportion setup. Okay, so when you do something like a quiz, you might have a proportion of 11 over t equals 100 over 11. You might have t over 11 equals 100 over 11. You might have t over 100 equals 11 over 11. And all these different setups using the same values, but then identifying which equation would belong to each of those proportions. Okay, so you want to make sure you know how to set the equation up, not just multiply and divide. Everybody clear on that? Okay. All right, so once we have actually set up the correct equation, we then, of course, would know that we're going to go ahead and divide both sides by 100, and that we would get t is equal to 1.21. Okay, so we'll do one more together again. We are going to do our cross product. So I'm going to multiply 5 and 13 together, and I'm going to multiply y and 10 together. So I know that when I'm creating my equation, I'm multiplying 10 times y, which is going to give me 10y. I am multiplying 5 times 13, which is going to give me 65. So then my equation is 10y is equal to 65. So I'm going to be asking you guys, what is the equation? 10y is equal to 65. And then what is the solution? The solution would be 6.5, because when we divide both sides by 10, we will get y is equal to 6.5. So I want you guys to do problems 3 through 6. Again, identify the equation and then identify the solution. So for problem number 3, Angeline, problem number 3, what was the equation that we set up? Okay, so 12y is equal to what? Which is 36. So our equation is 12y is equal to 36. Again, because she said she did 12 times y, and then she did 4 times 9. Okay, So we've got 12y is equal to 36. What is the solution to our equation then, Jeremy? Y is equal to 3, right? If we divide both sides by 12, we're going to get y is equal to 3. Okay, so our equation was 12y is equal to 36. Our solution was y is equal to 3. Daniel, for problem number 4, what was the equation? Okay, 7k equals what? 12.6, yeah. So just tell me the equation part. 7k is equal to 12.6, because again, we did 3 times 4.2, and then 7 times k. So then we get our solution. K is going to be equal to what value, Ava? 1.8. Okay, and that's because we divide both sides by 7. We're going to get k is equal to 1.8. All right, number 5. My equation, Nathaniel, what is my equation? For number 5. Uh-huh. Equals 80. Good. 5w is equal to 80. I'll change these to blue again. Okay, 5w is equal to 80. That's going to be the equation because we did 5 times w and 10 times 8. And then w, the solution for w is going to be equal to what, Amy? W is going to equal what? 16, right? Because we just divided both sides by 5, and we're going to get 16 for w. Okay, number 6, the equation is going to be what, Chase? Uh-huh. Uh-huh. Which is what? For the right side, 0.9 times 10 is? 9. Yeah, not 90, 9. Okay, again, 0.9 times 10 gives us 9. 0.5 times a gives us 0.5a. Okay, and then for our solution, a is going to be equal to what value, Christiana? Huh? 18. Very good, because we just divide both sides by 0.5. Okay, so again, making sure you know what the equation is, making sure you know the solution for it. All right, taking a look. It's not always just going to be handed to you. They're not always going to tell you, hey, here is your proportion, solve. Sometimes you have to create the proportion from a word problem or scenario here. So for problem 1, we have a 12-ounce bottle of shampoo is going to last Enrique 16 weeks. We want to know how long are we going to expect an 18-ounce bottle of that same exact shampoo to last him, the same brand. Okay, so when you are setting up your proportion, you're essentially setting it up as here is the information that is going to be given to you versus the information that you are being questioned about. So what the question is relating to. You're setting it up to information that has been given to you and setting it equal to the question that's being asked of you. So when we're looking through this problem, only information that's fully given to me is the first sentence here. That 12 ounces of a shampoo is going to last him 16 weeks. Now, I get to dictate how I want to set up that ratio. I can say 12 over 16, or I could say 16 over 12. Neither one of them is going to be wrong. Okay, they are both accurate ways to set up a ratio. However, the way that you set up your given ratio is going to determine how you have to set up your question ratio. Okay, so if I do 12 over 16, that's going to dictate how I have to set up the question. If I do 16 over 12, that'll change how I set up the question. So let me go ahead and show you right now. I'm just going to do 12 over 16. But I want you to notice I'm not going to just put the numbers. I'm going to put what those values represent. What does 12 represent? Ounces. So off to the side, I'm going to put that these are ounces. This information is going to be very helpful for me when I'm setting up my questions ratio. Okay? Then under 16, 16 is going to represent weeks. So right next to 16, we're going to write down that these are weeks. Again, this is going to help me when I have to set up the question, because the question's information is asking how long is 18 ounces going to last. So the only information that the question gave me was 18 ounces. Based off of how I set up my given, where do 18 ounces have to go? Top or bottom? Top, right? Because ounces were on the top in my given, therefore ounces is going to stay on the top in my question. So I'm going to put 18 ounces on the top. Now it's asking, how long am I going to expect it to last? The length that they're talking about is in what measurement? Weeks. So we know weeks is going to go, again, on the bottom, but it's an unknown value. So we're going to put a variable. I'm just going to put x. So here is the proportion that I have set up. 12 over 16 is equal to 18 over x. Now if I had flipped it, if I had done 16 over 12, then this would have to be x over 18. Okay, if I had decided that I wanted to put 16 weeks on top and 12 ounces on the bottom, I would have had to put x weeks on top and 18 ounces on the bottom. All right, now we can go ahead and do our cross product here. So when we're doing our cross product, again, we're going to multiply our diagonals. So I'm going to multiply 12 times the x, which is going to give me 12x. I'm going to multiply 16 times 18, which is going to give me 288. 16 times 18 is 288. So here's the equation that represents this scenario, that 12x is equal to 288. We would then solve, and how many weeks is it going to last, Ava? 24. It's going to last us for 24 weeks. So again, the nice thing about the word problems is that you are setting up the ratio how you want to set it up. But you can only set up the first one however you want. The second one will be determined based off of how you set up your first. Okay? So I want you guys to go ahead and try number 2 and number 3 on your own. Okay, who wants to tell me, how did you set the proportion up for problem number 2? We have 13 out of 20 homes that have a personal computer. On the street there are 60 homes, so we want to know how many are going to have a personal computer. So how did you set up the proportion, Nathan? Good. 13 over 20 equals x over 60. You could have also done 20 over 13 and then 60 over x. But basically that 13 represents how many people actually have computers. Right? There's 13 people that have a personal computer out of the 20 total homes that were on the block. And in here, we're trying to figure out how many people are going to have computers if there are 60 homes total on that street. Okay, so this portion right here, this is the given information that's been provided to us, and then this is the information that is based for the question that we are trying to provide an answer to. Okay, so then when we set that up, based off of how he set his proportion up, our equation again is going to be 20x is equal to 780. That should be your equation because you're multiplying 13 times that 60 and you're multiplying the 20 times the x. Okay, so you should have 20x is equal to 780. And then our solution, how many computers are we seeing there, Parker? 39. We're expecting there to be about 39 computers for these homes because, again, we're going to go ahead and divide both sides by the 20. All right, for problem number 3, in a class of 32 students, 8 were absent. If a school has 720 students, how many would you expect to be absent? So we want to create our proportion first. So what is our proportion going to look like, Jeremy? Huh? 8 over 32. Okay, you could have also done 32 over 8. Either one of them's fine. 8 over 32. Now, based off of you setting it up as 8 over 32, what does the other part have to look like? X over 720. Good. Okay, so he set it up, even though they said, hey, there's 32 students, 8 were absent, he set it up as absent students over total students, right? He set it up as how many were actually absent out of the total number of students that were in that class. So then we have X amount of absent students out of a total of 720 students in the school. So there's our proportion. Again, you could have done you could have done 32 over 8, but then 720 over X. Either of those would have been perfectly fine. Okay, when we create our equation, Ada, what's our equation going to look like? Ada. For the equation. Like, we had 20x is equal to 780. Once we've done our cross product, we created the equation. What's the equation going to be for number 3? Okay, do it now, because you can. Looking off of what he's got here, what would our equation be? Turn around. Okay, 32x. 5,760. Good. 5,760. So you're just multiplying 8 times the 720 and the 32 times the x. And that gives you the equation. 32x is equal to 5,760. Okay, and then the value for x. How many absent students could we expect for that day, Nathaniel? X equals 180. Okay, so we're expecting to have about 180 absent students based off of what we're seeing. Okay, because again, all we did was divide both sides by the 32. Okay, make sure again that you know how to set up the equation, how to set up the solution. Okay, in this process, you're also having the extra effort of setting up the proportion. All right, let's flip it on over to the next ones for problem 4 and 5. Since you guys were able to work pretty quickly, let's take a look at those. So for problem 4, Josh paid $3.72 for 3 pounds of apples. We want to know how much is 7 pounds of apples going to cost him. Okay, so let's go ahead and set up the information. So here's the information that was given, the price and the amount that we bought, and then here is the question that's being asked. How much is 7 pounds going to cost? Okay, so when we set this up, who can tell me what they did for their proportion? How did you set your proportion up? Sebastian. Okay. Okay, good. Okay. All right, so again, 3.72. Now this was money, so we're going to go ahead and put my dollar sign because I am talking about money. And then 3 represents the number of pounds of apples. Okay, X, again, I'm going to put a dollar sign there because I know that X is going to have to be money. And 7 represents the number of pounds of apples that would be purchased. Okay, so we have 3.72 over 3, and then X over 7. Based off of this, what is the equation going to look like? What will the equation look like for here? Christiana. Good. 3x is equal to $26.04. Okay, because again, we're going to multiply this together, 3.72 times 7, and we're going to multiply these together, 3 times the x. Okay, so we have 3x is equal to 26.04, or $26.04. And then what is the cost of 7 pounds of apples going to be? Angeline. $8.68. Yeah, $8.68. Good, because all you had to do was divide both sides by 3. All right, number 5. Jaden, how did you set up problem number 5's proportion?
62 over 93 is equal to 100 x over 174.
Good. Okay, so 62, which represents the minutes, over 93, which represents the pages, and he said that that's going to be equal to x, which is going to represent the minutes, over 171, which represents the pages. Okay, so there's the proportion that we were able to set up, because here's the information that was provided to us: 93 pages over 62 minutes, or 62 minutes over 93 pages. And then we've got the question: how long is it going to take her to read 171 pages based off of her reading average? Okay, so then we can do our cross product. So we're going to do our cross product to be able to set up our equation. Let's see here. Who have I not heard from? Jean-Luc. Jean-Luc, set up my equation here based off of what we've got.
62 times 171 and 93 times x.
Okay, and so 93 times x is just going to be 93x. And then what is the 62 times 171?
10,602.
Good. 10,602. Okay, because we're multiplying 62 times 171, and we're multiplying 93 times the x. All right, from there, we can then go ahead and divide both sides by 93. And Daniel, what do we get? Good, x is equal to 114, and that's representing minutes. All right, so that is basically taking information and you're creating different ratios, different rates. And the reason they call them rates is because you're comparing two different types of quantities to each other to create a fraction, right? Minutes and pages, or price and pounds, that kind of thing. So here in the next problem set is the actual percent proportion. Okay, you guys know it as part over whole equals percent over 100, but it also can be a setup of is over of equals percent over 100, where the is value represents the part of a problem, the portion, and the of value is going to represent the whole. And then, of course, your percent over 100, that never changes. This is always going to stay exactly as it is. It's always going to be a percentage out of 100 because the maximum percentage is supposed to be 100%. So when we're taking a look in a simple statement problem, these are simple statements. They're not word problems. They're not contextual. Yes, there are words, but they're not actual in context, okay? So these are simple statement problems where they are providing us the terms is and of instead of parts and whole. Okay, so we're trying to identify our is value, our of value, and our percent value. One of those three values is going to be a variable because it is missing. It is what we are looking for. But when we set this up, I always like to tell students just write out is, of, and percent, and then go through the problem to identify those portions. So the first thing we're going to do is look at the number 50. 50, is that an is, an of, or a percent? It's an is, right? It says 50 is. 50 is. So I'm going to go ahead and put a box, a green box around my 50 is, and I know that is value is going to be a 50. So when I'm setting this up, I'm going to put 50 on top. Okay, now the next one, 20. Is that a percent or an of? A percent. How do we know it's a percent? Because it says percent. Let me tell you, I've had many students who incorrectly place a percent value because they see the word percent, but they don't see the percent symbol. You will know it's a percentage if it has the percent symbol. If it does not have the percent symbol, it is not a percent. Okay, So this one happens to be a percentage. I'm going to go ahead and circle it in blue, and for percent, I'm going to put 20. That's going to go on the top for my second ratio over 100. So the part that happens to be missing is the of. It says of what number? Of what number? That's my variable. So we're going to put 50 over x is equal to 20 over 100. 50 over x equals 20 over 100. Is over of equals 20 or percent over 100. Okay, and then we can go ahead and do our cross product. I would multiply 20 times the x to get me 20x. I would multiply 50 times 100, and that's going to give me 5,000. Okay, from there, because I'm solving for my x, I'm just going to go ahead and divide both sides by 20. And I would get that my of value is 250, so there's my whole. Now, that makes sense because my is should be smaller than my of. My part should be smaller than my whole because my percentage is less than 100%. If my percentage was more than 100%, then my part would be bigger than my whole. Does that make sense? When your percent is under 100, your part is smaller than your whole. When your percentage is larger than 100, your part is larger than the whole. What if your percent is equal to 100? Then your part and your whole are the same. Okay? Go ahead and do 2 through 4. Yes. Huh? No, because we're actually going to do the next page tomorrow because we're running out of time. For problem number 2, the is going to be the 4. Is going to be equal to 4, so we're going to put 4 on top. Of is going to be equal to 20, so that's going to go underneath the 4. And then our percentage is the value that happens to be missing. We do not know our percentage, so we're going to put the variable x. So this is going to be x over 100. When we do our cross product, we're going to do 20 times x to get 20x. We're going to set it equal to 4 times 100, which is 400. And then when we divide both sides by 20, we're going to get that x is equal to 20%. Okay, for problem number 3, our is value is going to be equal to 60. So we're going to put that on top. Our of value is missing because it says of what number. Of what number, so that's going to be x. And then, of course, our percentage is 25%. So we're going to put it equal to 25 over 100. Okay, when we do our cross product, we're going to do 100 times 25, which gives us 25x. Or sorry, not 100 times, 25 times x, which is 25x. And then 60 times 100, that's going to give us 6,000. And then, of course, we would then divide both sides by 25. And we'll get that x is going to be equal to 240. Then our last problem, what number is, that's the value that happens to be missing. That's our variable, so x is going to go on top. Of 1,000, that's going to be our of. So 1,000 is going to go on the bottom. And then our percentage is 32. So we'll have 32 over 100. And then cross product, you should get x is equal to 320 once you have finished. All right, I'll see you guys tomorrow. Yes, you may open the door. All right.